Petropolis is rolling out public Wi-Fi. And you and I are going to handle the subnetting for that public Wi-Fi, and in so doing, learn how to break Class A networks into multiple subnets based on specific host requirements. So here's the story. Petropolis would like to implement public Wi-Fi at each one of their stores and regional offices using subnets of 10.0.0.0/8. Each segment should handle up to 1,000 host IP addresses. Guys, this is normal. I know it's like 1,000. Yeah, because a lot of times public Wi-Fi is just like, sometimes people just have it wide open with no password whatsoever, so people can come in the pet store with their cell phones and their iPads and their tablet, all the widgets that people have nowadays, and just join it and not worry about it. We make it a subnet of a large subnet, so we just don't have to think about it running out of IP addresses, and we segment it off using firewall rules so that it has no chance of reaching anything on the corporate network. So totally normal to see this kind of thing. And in a large enterprise like Petropolis, you've got a ton of stores. So they're just saying, just take the entire Class A network, 10 dot whatever, anything that starts with 10, and chop that up into little segments that we can use for our public Wi-Fi. So here's the process that you would use to do that. Now, it is the same process as it was before, and I would encourage you, before you just kind of watch me go through it, pause right now and see if you can figure this out yourself, okay? So here we go. I'm going to convert the number of hosts to binary. Now, we've got 1,000 host IP addresses, 1,000. I'll write out our binary chart, 128, 64, 32, 16, 8, 4, 2, and 1. Full well knowing that we can't get 1,000 with just 8 bits, so I'm going to have to go further. 256, 512, 1024, and right there I stop because we passed it. Now, don't make the mistake. It's easy if you're going fast to be like, oh, okay, so I need that many bits. No. The first thing that you can subtract, the first one essentially in binary, goes in that 512 slot. So you actually need a total of 10 bits to get the number 1,000. So 1,000 equals 10 bits, right? Now, we're in a reverse world to where we're not focused so much on the number of networks that we can get. We're focused on the number of hosts per network. So I'm going to say my /8. Here's my subnet mask in all binary. And remember, we are focused on saving the host. Save the host IP addresses because I cannot get the number 1,000 with any less than 10 bits. So I'm going to look right here and go right to left. 1, 2, 3, 4, 5, 6, 7, 8, dot, 9, 10 will be saved. There's my 10 bits. The rest of them can flip on over to the network side. Because again, we are doing subnetting. We don't want one big old network of 10 with 16 million hosts on it. We need subnets, and it looks like we're going to get a lot of them because our new subnet mask becomes a / that'd be 8, 16, 17, 18, 19, 20, 21, 22, or in decimal 255.255.252.0. Our increment is that lowest network bit converted back to a decimal number. So again, increments start over every single octet. 1, 2, 4, right? It's in the third octet. So our public subnets look like this. 10.0.0.0, 10.0.40, 10.0.80, 10. You see where I'm going here? 10.0. 12.0, and down and down and down we go. Fill in the end range. This goes through 10.0.3.255 through 10.0.7.255 through 10.0.11.255, and we've got it. How many networks, or I should say, how many hosts do we get on each one? Well, we've got 2 to the power of 10, and I know just because I've got my 11 bits here, this is 2 to the power of 0, 1, 2, 3, right there. We're actually going to end up with 1,024 minus 2 hosts per network. So 1,022 individual hosts that can join that public Wi-Fi. The total number of subnets would be found using 8, 9, 10, 11, 12, 13, 14. So it would be 2 to the power of 14. Calculator, 2 to the power of 14. Enter 16,384. I know Petropolis is a massive store. They sell hedgehogs. 16,384 public Wi-Fi networks should do. And we don't have to subtract 2 from that number because we can use the first and the last network. Now, good exercise, yeah? Yeah, you feel like you got Class A and previously B and C down now. And I think you're really, I don't know, I've done this enough to where I feel like you should be at this point going like, yeah, I got it. You're just nodding your head. You're like, yep, bingo, exactly what I got. That's what I'm thinking. Now, let me throw a little whoosh, real world at you. Usually, you don't worry about creating unique networks for public Wi-Fi. Here's what I mean. Let's look back at this picture. If you've got Petropolis, and let's just say you've got all of these individual stores right here, right? Each one of those stores looks like it connects to the public headquarters. And what usually will happen is each one of those stores will get a internet connection of its own. Now, it's not always that way. You might have all of these guys go through the Petropolis headquarters and consolidate all your internet costs by using one giant internet connection from here. But a lot of times people like the redundancy, eliminating that single point of failure where if that WAN link goes down, they can use a little small DSL or cable modem connection and access the internet and set up a VPN. This is, by the way, you would use something, technology called DMVPN. That's dynamic multi-point VPN, to where when this connection were to go down, if it were to go down, these sites would dynamically form a VPN connection to Petropolis through the internet. It wouldn't have quality of service, but it would at least give connectivity over there. Now, if that's the case, which is what most stores do, and I'm just throwing a little real world in for you. So if that's the case, then each one of these stores would take that public subnet and they would just duplicate it all over the place. So they might use, let's just say 10.1.1. That's a bad example. Let me just go easy. I'm not going to do subnet. Let's just do 10.0.0.0/24. They just throw a network of 254 usable hosts from 10.0.0.0 to 10.0.0.255, right, at each one of these sites. And they just reuse it because that subnet lives and dies at the store. They would never let that subnet cross to the Petropolis headquarters, right? Because it's a public subnet. You wouldn't want, somebody's public phone, smartphone getting on your network and being able to access servers that are sitting up here at Petropolis. You would just route that out and NAT it, network address translation, right out to the internet. Because that's really all people that are using a public subnet. I'm blending. Public subnet gives the idea of public IP addresses. I mean, like a public Wi-Fi. That's all they're really interested in, is using it to connect to the local internet anyway. So while it's a good exercise, normally you wouldn't chop up your entire 10.x addressing scheme just for public Wi-Fi. Regardless, you've now seen how to break Class A networks into multiple subnetworks based on specific host requirements. I hope this has been informative for you, and I'd like to thank you for viewing.